Good morning, students. Exercise 10.8, the problem number 10. A tank initially contains 50 liters of pure water. Starting time t is equal to 0. A brine containing with 2 grams of dissolved salt per liter flows into the tank at the rate of 3 liters per minute. The mixture is kept uniform by stirring, and the well-stirred mixture simultaneously flows out of the tank at the same rate. Find the amount of salt present in the tank at any time t is greater than 0. Okay, you see, a tank initially contains 50 liters of pure water. So when t is equal to 0, a brine is nothing but a high concentration solution of salt, that is NaCl solution. That brine containing with 2 grams of dissolved salt per minute. So the NaCl solution containing 2 grams of salt per liter. That means 1 liter of brine contains 2 grams of salt. Okay, so the brine, that is the concentrated NaCl solution, flows into the tank at the rate of 3 liters per minute. That means 1 minute 3 liters of brine it flows into the tank. Okay, per 1 minute the 3 liters of brine flows into the tank. And you see that the mixture is kept uniform. Already 50 liters of pure water is there. Per minute 3 liters of brine is flowing in. So it has to mixed. So the mixture is kept uniform by stirring, and the well stirred mixture simultaneously flows out of the tank at the same rate. You see that the mixture flows out of the tank at the same rate. So what the rate it moving, it flows into the tank, the same rate it flows out. Okay, so see that here per minute 3 liters of brine flows into the tank. Okay, so the same rate, that means per minute 3 liters of mixture flows out of the tank. Okay, then we have to find the amount of salt present in the tank. Okay, first we have to denote X, denote the amount of salt in the tank at time t. So X ingradu, it is nothing but the amount of salt present at any time t. So the rate of change of salt is nothing but, the formula is inflow rate minus outflow rate. Okay, you see salt is denoted by the variable x. The rate of change of salt is dx by dt is equal to inflow rate minus outflow rate. So inflow rate means how much of salt is flowing into the tank according to the time. Outflow rate means how much of salt flows out of the tank with respect to time. So that only we have to find out. So we are moving to find the inflow rate of the salt. Inflow rate of the salt. Okay, you see that the brine containing what it is, 2 grams of salt per liter. So 1 liter of brine contains 2 grams salt. Okay, so per minute how much liters of brine is moving in? So 3 liters. So 1 liter contains 2 grams of salt, means 3 liter contains 3 into 2, 6 grams of salt. So 6 grams of salt flows into the tank per minute. Okay, so salt alone we are seeing. So 1 liter contains 2 grams of 2 grams salt, means 3 liters, that the 3 liters of brine contains 6 grams of salt. So per minute 6 grams of salt along with the brine is flowing into the tank. So the inflow rate of salt is 6 grams. Okay, so we'll move to the outflow rate of the salt. We are moving to find outflow rate of the salt. You see that at the same rate the mixture is flows out. So that means 3 liters per minute. So the outflow rate of brine is 3 liters per minute. Okay, that means so it is 3 by 50 of the total brine content in the tank. Okay, so that means what, that is 50 liters of pure water already there. So per minute 3 liters of brine is moving, flows into the tank. Then it is the mixture is stirring and the mixture flows out of the tank 3 liters per minute. So 3 by 50 of the total brine content in the tank. Tankல இருக்கிற total brine contentல 3 by 50 of brine is flows out per minute. Okay, so the outflow rate of salt is 3 by 50 of X. X already we have denoted the amount of salt present in the tank. So the total brine content in the tank 3 by 50 of X is flows out of the tank per minute. So therefore the outflow rate of salt is 3x by 50. Okay, so what is the formula we have used? It is a rate of change of salt, that is dx by dt, that is equal to inflow rate minus outflow rate. The inflow rate is 6, the outflow rate of salt is 3x by 50. So you have to take LCM. 6 into 50 is 300. 300 minus 3x by 50. From that minus 3 is taken out. If the minus 3 is taken out, here you will have x, that is in positive, and here from this 300 if you take minus 3 out, it is minus 100. Okay, so see now minus 3 by 50 is a constant, you just keep in the right side itself. This dt has to be brought to the right side in the numerator, and here you are having in the right side you are having x minus 100. You have to it has to be brought to the left side in the denominator. Here in the left side we got the variable x, and the right side we are having the variable t. So we have separated the variables x and t. Next you have to integrate. So integrate on both the sides. So see now dx by it is in the form of dx by ax plus b. So in the place of x the coefficient is 1. So the answer is dx by x. So it is log of x minus 100, that is equal to minus 3 by 50 is a constant. Integral dt is t plus c. So x minus 100, the log when you take it to the right side it will become exponential. So e power minus 3 by 50 t plus c. So the power is in addition. If you want to write multiplication, that can be written as e power minus 3 by 50 t into e power c. So e power c is a constant. So we can write the arbitrary constant as c. So c into e power minus 3 by 50 into t. So x is equal to minus 100 when you take it to the side, that is right side, 100 plus c e power minus t minus 3t by 50. Okay, so this is the amount of salt present at time t. But here we can find c. So see that first starting a tank contains 50 liters of pure water initially. So that is the first sentence. A tank initially contains 50 liters of pure water. Okay, so when t is equal to 0, the amount of salt is 0 because the tank contains 50 liters of pure water. Okay, no brine is added initially. So x is equal to 0. So if you substitute x as 0, 0 is equal to 100 plus c. In the place of t as 0, so e power 0. So e power 0 is 1. 1 into c. So here you will have c here. So this 100, when you take it to the left side, it is minus 100. So c value we have found, it has to be substituted in the second equation. So therefore x is equal to 100 minus 100 into e power minus 3t by 50. So here it is written like this. From these two terms, 100 is common. If you take it out, 1 minus, so e power minus 3t by 50. So this much amount of salt is present in the tank at any time t. Okay, so we'll come to 7th problem, exercise 10.8, 7th problem. You see that the water at temperature 100 degrees Celsius cools in 10 minutes to 80 degrees Celsius in a room temperature of 25 degrees Celsius. So question 5, find first subdivision, the temperature of water after 20 minutes. Second one, the time when the temperature is 40 degrees Celsius, and the log value is given to you here. See now, here water at temperature 100 degrees Celsius cools in 10 minutes to 80 degrees Celsius and in a room temperature. So first we need the variables for the temperature of the water and the room temperature. So let capital T be the temperature of the water and S be the room temperature at any time t. So this is small t is the time and capital T is the temperature of the water and S be the temperature of the room. Okay, so according to Newton's law of cooling, so by Newton's law of cooling, you see the rate of change of temperature of the body is directly proportional to the difference between the temperature of the body and the surrounding medium. That is the Newton's law of cooling. What the word I have, what the sentence, what I have started, the rate of change of temperature of the body. So here in the place of body, here we are taking the water. So the rate of change of water, that is the water, the temperature of the water is denoted as, what is it, capital T. So the rate of change means dt by dt with respect to time. What is the change in the temperature? So it is denoted as d capital T by dt is directly proportional to the difference between the temperature of the body and the surrounding medium. So the temperature of the water minus the temperature of the surrounding medium, here it is a room, so T minus S. So the proportionality symbol has to be removed. For that we have written the constant K. K is the constant of proportionality. So now you have to separate the variables. So dt should be in the numerator. So bring this T minus S to the left side in the denominator. So we can write in the right side K into dt. So you have to integrate on both the sides. So if you integrate this term, integral dt by T minus S is log of T minus S is equal to, what is it, kt. How does kt has come? K is a constant. What is integral dt? That is t plus c. Okay, so as usual T minus S is equal to e power kt plus c. If you want to write multiplication, e power kt into e power c. So e power c can be written as c. So T minus S is equal to c into e power kt. So from the, we formed the differential equation, from we have solved and we have written in the expression in terms of capital T and small t. Okay, next you have to apply the initial condition. So you see that first, water at temperature 100 degrees Celsius. Okay, so first the temperature of the water is 100 degrees Celsius. So initially the temperature of the water is 100 degrees Celsius. So initially how we can mention T is equal to 0. The temperature of the water is 100 degrees Celsius. And here also we need S. S is nothing but the room temperature. It is a constant. So the room temperature given here is 25 degrees Celsius. So S is equal to 25 degrees Celsius. All the three has to be substituted in 1. So what is capital T? That is 100 minus, what is the room temperature? 25 is equal to C. When you substitute T as 0, it is e power 0. So e power 0 is 1. C is equal to 100 minus 25 is 75. The C value has to be substituted in the first equation. So you are getting T minus 25 is equal to 75. In the place of C, you have substituted 75 into e power kt. So initial condition is over, and we have to go to the given condition. You see that water at temperature 100 degrees Celsius cools in 10 minutes to 80 degrees Celsius. That means starting the temperature of the water is 100 degrees Celsius. After 10 minutes, it changes to 80 degrees Celsius. That is, it cools to 80 degrees Celsius. So when T is equal to 10, that is 10 minutes, the temperature of the water is 80 degrees Celsius, and it has to be substituted in the second equation. So it is T is what? 80 now. 80 minus 25, the room temperature is constant, so that is 25. So 80 minus 25 is equal to 75 e power. In the place of T, what you have to substitute? 10. So 10 into K, e power 10K. So 80 minus 25 is 55, divided by the 75. We can bring it to the left hand side in the denominator. So 55 by 75 is equal to e power 10K. So from this you can find the value of K. So E, when you bring it to the next side, it is log of 11 by 15. How 11 by 15 has come? If you divide it by 5, 55 can be written as 11 and 75 can be written as 15, because in the problem it is given log 11 by 15. So we can bring it to the logarithmic term, is equal to 10K. From that, what is K? This 10 will go to the left side as 1 by 10. So K is equal to 1 by 10 log of 11 by 15. So K is equal to 1 by 10 log of 11 by 15. So given condition is applied and you have found the value of K. Next, according to the, we have to find what is asked. In the first subdivision, the temperature of the water after 20 minutes. So when small t is equal to 20, what is the temperature of water? So T is equal to what? When small t, the time is equal to 20 minutes. So this result has to be substituted in the second equation. So the second equation is here. So T only we have to find out. So T minus 25 is equal to 75 e power, what is the time? 20. So e power 20K. So you have written this term. So T minus 25 is equal to 75 e power 20K. Already we have found e power 10K, isn't it? So e power 10K is what? It is 55 by 75. If you simplify, it is 11 by 15. So e power 20K can be written as e power 10K the whole squared. Otherwise you can write e power 10K into e power 10K. That also you can write. E power 10K we have written as 55 by 75. If you simplify, that is 11 by 15 the whole squared. So if you square the 11 squared is 121, divided by 15 the whole squared is 225. If you divide it by 5, it is 15 divided by 45. If you cancel with 15, 115 is 15, 3 15s are 45. So 121 by 3. If you divide, your answer is 40.333. It goes on. So T is equal to 40.33 plus 25. So if you add, your answer is 65.33. So therefore, the temperature of water after 20 minutes is 65.33 degree Celsius. So see the second subdivision, what is asked? The time when the temperature is 40 degrees Celsius. The time. So see then the first subdivision what is asked? The temperature of the water. So the capital T is equal to what? When small t is equal to 20. Okay, that is asked. Here the time means it is nothing but small t when the temperature is 40 degrees Celsius. So therefore what is given? Capital T is equal to 40 degrees Celsius is given, and what is asked? T is equal to what? Okay, so see now T is equal to the time we have to find, and when the temperature is 40 degree Celsius. So where you have to substitute this result? We have to substitute in the equation 2. So that is the final equation. So here what is the temperature of water now? 40 degree Celsius. So in the place of T we have substituted 40 minus 25 in the second equation is equal to 75 e power k into t. This time small t we have to find out. So therefore 40 minus 25 is equal to 75 e power kt. 40 minus 25 is what? It is 15. Bring the 75 to the left side in the denominator. So 15 by 75 is equal to e power kt. So if you cancel with 15, it is 1 by 5 is equal to e power kt. So here in the problem it is given log 5. So therefore we have to change in terms of log. So this e, when you bring it to the left side, it will become logarithmic function. So log of 1 by 5 is equal to kt. So t only we have to find out. So the k, when you take it to the left side, it is 1 by k. So 1 by k log of 1 by 5. So t is equal to, already we have found what is k. So see now the k value is, what is k value? We have found is 1 by 10 log of 11 by 15. Okay, so k value already we have found, it is 1 by 10 log of 11 by 15. So here your k, where it is in the denominator. So the k value is substituted here. So 1 into log of 1 by 5 divided by, what is k value? 1 by 10 log of 11 by 15. Where is the 10? 10 is in the denominator of the denominator. So it will come to the numerator. So that's why 10, 1 into log of 1 by 5 is log 1 by 5 divided by log 11 by 15. But in the problem it is given log 5 only. See that question? That question, log 5 to the base e is given. Okay, so here we have written log 1 by 5. So this 1 by 5 we can write as log 5 to the power minus 1. You see now, log 5 to the power minus 1. 5 to the power minus 1 is nothing but 1 by 5. So here 1 by 5 is there. So I have changed as 5 to the power minus 1. How it look like? Log a power m. So log a power m can be written as log m log a. So the minus 1 will come to the front. So minus 1 into 10 is minus 10 log 5 divided by log 11 by 15. So the values has to be substituted, the given values. For log 5, its answer is given 1.6094, and log 11 by 15 is minus 0.3101. So it is substituted. Already minus is there. So minus and minus plus, and if you multiply with 10, you will get 16.094 divided by 0.3104. Okay, if you remove the decimal place in the denominator, you have to multiply with, what is that, 10,000. So you will get the numerator is this much divided by 3104. So the division I have written here. So you just go through that. So the t value is approximately 51.849. So therefore, the time when the temperature of the water is 40 degrees Celsius is approximately 51.9 minutes. Okay, we'll come to the problem number 9. A pot of boiling water at 100 degrees Celsius is removed from a stove and at time t is equal to 0 and left to cool in the kitchen. The pot of boiling water at 100 degrees Celsius is removed from a stove at time t is equal to 0 and left to cool in the kitchen. After 5 minutes, the water temperature has decreased to 80 degrees Celsius and another 5 minutes later it has dropped to 65 degrees Celsius. Determine the temperature of the kitchen. Okay, so first whatever it is, we have to denote the temperature of the body and the surrounding medium. So here T be the temperature of the water and S be the temperature of the kitchen. Here the surrounding medium is kitchen, let S be the temperature of the kitchen. So by Newton's law of cooling, already I have said dt by dt is proportional to t minus s. The proportionality has to be removed and we have to separate the variables, and if you integrate you will get t minus s is equal to e power kt plus c. Okay, so t minus s is what? C e power kt. So we have solved the differential equation and brought the expression in terms of capital T and small t. Okay, so you see that pot of boiling water at 100 degrees Celsius. So what is 100 degrees Celsius? It's a temperature of the water initially. Okay ma'am. So when T is equal to 0, your temperature of the water is 100 degrees Celsius. So it has to be substituted in the first equation. So 100 minus S. S is not given. That is the kitchen temperature only we have to find out. So S has to be written as it is equal to C e power 0 because the time is 0 initially. So C is equal to 100 minus S. The C value has to be substituted in the first equation. So in the place of C, 100 minus S, and mark this as equation 2. So initial condition is over. Next we have to apply the given condition. You see, initially 100 degree Celsius, that water, it is removed from the stove at time t is equal to 0 and left to cool in the kitchen. After 5 minutes, the water temperature has decreased to 80 degrees Celsius. So second sentence has to be used. Okay, after 5 minutes, that is small t, the time is equal to 5 minutes. The temperature of the water is what? It has decreased to 80 degrees Celsius. So therefore capital T is equal to 80 degrees Celsius. So it has to be substituted in the second equation. So in the place of t, what you have to write? 80 minus S, we don't know, we have to find it, is equal to 100 minus S into e power, how 5 minutes, t is equal to 5. When you substitute t as 5, it is e power 5k. From that you just find e power 5k. This 100 minus S has to be brought to the left side in the denominator. So we have applied the given condition and we have written e power 5k. Then what is asked finally? You see, and another 5 minutes later it has dropped to 65 degrees Celsius. Determine the temperature of the kitchen. So the temperature of the kitchen, here the kitchen is the surrounding medium. So the surrounding medium is S. So we have to find S. Before that, you just apply this. And another 5 minutes later, it has dropped to 65 degrees Celsius. Another 5 minutes, already 5 minutes is over. After 5 minutes, so I am going to take, when t is equal to 10 minutes, totally starting the 10 minutes, when t is equal to 10 minutes, your capital T, the water temperature is 65 degrees Celsius. So these two results has to be substituted in the second equation. So in the place of capital T, what you have to write? 65 minus S is equal to 100 minus S into e power. Here what is your T? 10k. So e power 10k is what? This 100 minus S has to be brought to the denominator. So e power 10k is equal to 65 minus S divided by 100 minus S. This e power 10k, how you can write? E power 5k into e power 5k, because e power 5k we know that answer. So e power 5k into e power 5k. So e power 5k is what? 80 minus s divided by 100 minus s. So it is substituted. And you see that 100 minus s, here also 100 minus s getting cancelled. The remaining is 65 minus s is equal to 80 minus s the whole square divided by 100 minus s. If you cross multiply, 65 minus s into 100 minus s is equal to 80 minus s the whole square. It is in the form of a minus b the whole square. So a minus b the whole squared is a squared 6400, that is 80 the whole square, that is 6400, plus b squared, that is s squared, minus 2ab, 2 into 8 is 160, so minus 160s. If you multiply these two, it is 65 into 100 is 6500, minus 65s and minus 100s plus s squared. Minus s into minus s is plus s squared. So you are getting this. So 6500 in the left side. Bring the 6400 to the left side as minus 6400. And this s squared, and here you are having s squared. Both the sides s squared getting cancel. So here minus 65s minus 100s is minus 165s. Bring it to the right side, it will become plus 165s. If you subtract, it is 5s. 5s is equal to, what is 6500 minus 6400 is 100. So s is equal to 100 by 5, that is equal to 20. What is s? S is nothing but the surrounding medium temperature. Here the surrounding medium is what? Kitchen. So the temperature of the kitchen is 20 degree Celsius. We are moving to the problem number 8. You see that at 10 a.m. a woman took a cup of hot instant coffee from her microwave oven and placed it on a nearby kitchen counter to cool. So 10 o'clock, woman he took a cup of coffee and placed it on the kitchen to cool. So at this instant, the temperature of the coffee was 180 degree Fahrenheit, and 10 minutes later it was 160 degree Fahrenheit. Okay, so when t is that is 10 o'clock, the temperature of the coffee is 180 degree Fahrenheit. After 10 minutes, that is 10:10, it was 160 degree Fahrenheit. Assume that the constant temperature of the kitchen was 70 degree Fahrenheit. So here it is given the temperature of the kitchen, that is a surrounding medium. It is constant, that is 70 degree Fahrenheit. So the two subdivisions are asked. What was the temperature of the coffee at 10:15 a.m. So after 15 minutes, what is the temperature of the coffee? The next second subdivision is, the woman likes to drink coffee when its temperature is between 130 degree Fahrenheit to 140 degree Fahrenheit. Here the woman likes to drink the coffee between 130 degree Fahrenheit to 140 degree Fahrenheit. So what time should she have drunk the coffee? So we have to find the time. So within the what is the time the woman should have drunk the coffee? So it is asked. So whatever it is, we have to declare the variable. What is T? T is the temperature of the coffee, and S is the temperature of the kitchen. Okay, that is a surrounding medium. So we have to use the Newton's law of cooling. That is, the rate of change of temperature is proportional to the difference between the temperature of the body and the surrounding medium. So from that, the proportionality is removed. For that, the constant K is added. So what you have to do, you have to separate the variable, and if you integrate, so you will get the relation T minus S is equal to C into e power kt. So the previous problems I have explained, the same step is followed. So from the differential equation, and we solved it, and we found the expression in terms of capital T and small t. So first here what is given? 10 o'clock. So 10 o'clock, 10 a.m. What is the temperature of the coffee? It is 180 degree Fahrenheit. So 10 a.m. has to be taken as small t is equal to 0. So starting the time is 10 a.m. So that has to be taken as t is equal to 0. So when t is equal to 0, the temperature of the coffee is what? 180 degree Fahrenheit. Capital T is equal to 180 degree and S is equal to 70 degree Fahrenheit. That is the kitchen temperature. So all the three has to be substituted in the first equation. What is capital T? 180 degree. So that is 180 minus what is the kitchen temperature? 70 is equal to C e power, in the place of t you have to substitute 0, so e power 0 is 1, so C is equal to 110. 180 minus 70 is 110. After finding C, it has to be substituted in the first equation. So T minus this surrounding medium temperature is constant, so we can write 70 is equal to, in the place of C what you have to write? 110. 110 e power kt. So call this as equation number 2. And you see that 10 a.m. the temperature of the coffee is 180 degree Fahrenheit. And 10 minutes later it was 160 degree Fahrenheit. So after 10 minutes, so when T is equal to 10, the temperature of the coffee is 160 degree Fahrenheit. These two values has to be substituted in the second equation. So what is the temperature of coffee? That is T 160 minus 70 is equal to 110 e power. In the place of T what you have to substitute? 10. Okay, so it is 10k. So it is written here. From this e power 10k is what? 160 minus 70 is 90. Bring this 110 to the left side in the denominator. So e power 10k is equal to 90 by 110. So 0 getting cancelled. So e power 10k is equal to 9 by 11. Okay, from that we can find k. So here in this first subdivision we are not going to use k, we are using only e power 10k. So we'll see. Next, what is asked? Given condition is applied. Next you have to find what is asked. So what is the first one? What was the temperature of the coffee? What is the variable we have declared for temperature of the coffee? That is capital T. So we have to find capital T at 10:15 a.m. So therefore T is equal to 15 minutes because 10 a.m. we have taken as T is equal to 0. So 10:15 a.m. means when small t is equal to 15 minutes. So capital T has to be found when T is equal to 15 minutes. So where this result has to be substituted? It has to be substituted in the second result. What is the second expression? That is the second equation. T minus 70 is equal to 110 e power kt. Okay, so capital T only we have to find out. So you have to write T minus 70 is equal to 110 e power, what is small t now? 15. So e power 15k. So I have written here. But already the previous step we have found e power 10k. So we have to use e power 10k to write 15k. So e power 10k to the power 3 by 2. So if you multiply 10k into 3 is 30k. 30k divided by 2, what is it? 15k. So e power 15k can be written as e power 10k to the power 3 by 2. So e power 10k value we know, that is 9 by 11 to the power 3 by 2. 3 by 2 means what? It is 1.5. So the power 1, 9 by 11 to the power 1 and 9 by 11 to the power half. So to the power half means it's a square root of 9 by 11. So see now here 11 and 110 getting cancelled. So here you will have 10, 9 divided by these two getting cancelled here, 9 here in this term you will have only 9. What is square root of 9? That is 3 and divided by square root of 11. If you multiply the numerator, that is 270. 9 3s are 27. 27 into 10 is 270 divided by root 11. So multiply and divided by root 11. 270 root 11 divided by root 11 into root 11 is 11. So root 11, the square root I have found here, that is 3.316. Okay, approximately we can take 3.32. Okay, so you have to multiply. So the multiplication is here 896.40 divided by 11. If you divided by 11, 8 11s are 88. So here 1 is remaining 16, 1 11s are 11, remaining is 54. Okay, so here you will have 4 11s are 44. So the remaining you will get, so it is approximately t minus 70 is approximately 81.4 something else. Okay, so t is equal to what? T is equal to the minus 70, you have to take it to the next side as plus 70. So if you add these two, it is 151.4. So we can write the temperature of the coffee at 10:15 a.m. is 151.4 degree Fahrenheit. And you see the second subdivision, what is asked? So when the coffee temperature 130 degree Fahrenheit and 140 degree Fahrenheit, what time it should be, we have to find out. So capital T is equal to 130 degree. So you have to substitute in the second equation. So in the place of capital T, you have to substitute 130. So 130 minus 70 is equal to 110 e power kt. This T only we have to find out. So therefore, this equation will come. So 130 minus 70 is 60 divided by 110 is equal to e power kt. So 0 getting cancelled, log of 6 by 11 is equal to kt. So t is equal to 1 by k into log of 6 by 11. Okay, so already on the first subdivision, while you are finding, we have found the value of k. You see that? E power 10k is equal to 9 by 11. This term is there. From that we can find k. How it is? E, when you take it to the next side, it is log. So log of 9 by 11 is equal to 10k. Above here k is equal to 1 by 10 log of 9 by 11. So this k value has to be substituted here. So k is in the denominator. So it is in the denominator 1 by 10 will come. So 1 by 10, you can, the 10 will go to the numerator. So 10 into log of 6 by 11 divided by the k value is here log 9 by 11. That should be in the denominator. See here 1 by k. So 1 by 10 log of 9 by 11. So 1 by 10 is in the denominator. So the 10 will go to the numerator. So 10 log of 6 by 11 divided by log of 9 by 11 is equal to t. This has to be calculated. So 10 into log 6 by 11. How it is? Log a by b. Log a by b can be written as log a minus log b. In the same way, log 9 by 11 can be written as log 9 minus log 11. So you have to take the log value, and if you subtract, you will get this answer. And minus minus getting cancelled, you have to remove the decimal places. So 2632 divided by 871. If you multiply, 26,320 divided by 871. So you will get 30.31. So T as 30.31 when the temperature, the coffee is 130 degrees Fahrenheit. In the same way, in the problem it is given when the temperature of the coffee between 130 to 140 degree. So here next you have to take T is equal to 140. So this has to be substituted in the second equation. So in the second equation, what it is? It is T minus 70. T minus 70 is equal to 110 e power kt. So now your T is what? 140. So 140 minus 70 is equal to 110 e power kt. So 140 minus 70 is what? It is 70 divided by 110 is equal to e power kt. So in the e, when you take it to the left side, it is log of 7 by 11 is equal to kt. So T is equal to 1 by k log of 7 by 11. So k value is what? 1 by 10 log of 9 by 11. So here you have to substitute 1 by 10. So the 10 will go to the numerator. So 10 into log of 7 by 11 divided by log of 9 by 7. Log of 7 by 11 can be written as log 7 minus log 11. So that value is written here. Already we have found the log of 9 by 11. So those value has to be substituted. Okay, see that in the previous t is equal to 130 degree, we have found log 9 minus log 11. So those value, the denominator value is substituted here. Okay, so if you remove the decimal place, it is 9163 divided by 871. If you multiply with 10, it is 19,630 divided by 871. Okay, if you divide it, your answer is 22.53 minutes. So, when capital T is equal to 130 degree, when capital T is equal to 130 degree Fahrenheit, your time when you will get T is equal to small t is equal to 30.31 minutes. Okay, your capital T is equal to 140 degree Fahrenheit means your small t we have found is it is 22.53. Okay, so you see now starting time is 10 a.m. So after 30 minutes the temperature of the coffee will be, temperature of the coffee is 130 degree Fahrenheit. After 22 minutes the temperature of the coffee is 140 degree. So when you calculate the time, so 10:22 a.m. to 10:30 a.m. then only the woman should have drunk the coffee. So final conclusion, the woman should have drunk the coffee between 10:22 a.m. to 10:30 a.m. Thank you, students.